In this video, we're going to be looking at determinant of matrices. So when we speak of determinant of matrices, we are actually talking about determinant of square matrices, because you cannot take determinant of any other matrix except that of a square matrix. And then commonly at this level, the basic determinant that we handle are determinant of a 2 by 2 matrix and a 3 by 3 matrix. So let's look at what we have here. So if you have a 2 by 2 matrix A, B, C, D, and you are to take the determinant of this matrix, what you are going to do is you are going to multiply this diagonal element here, AD, which is what we have here, and you are going to subtract it from the multiplication of BC. Multiply AD and then multiply BC, then subtract BC from AD, and that is your matrix. And the matrix, that is your determinant. The determinant can also, let's say this is matrix A, so this is determinant of A, right? So the determinant of A could also be written this way, determinant of A. So now let's also say this is a determinant of B, determinant of matrix B. Now this is a 3 by 3 matrix. So for a 3 by 3 matrix, it's more interesting. Let me write this out. Let's consider this plus, minus, plus. Let's consider this. So this matrix is a 3 by 3 matrix. A1 is a 3 by 3 matrix. So to get the determinant of this matrix, right, is just like saying A1, pick this first element out, pick A1, then multiply it by this, right? Multiply it by the determinant of this. So which means that once you are picking A1, all this first row and first column is deleted. You are only picking A1, multiplying it by the determinant of B2, C2, B3, C3, right? Then the first element here is plus, so when you get to this, you are now going to use minus. So this will now be minus B1, right? So now, since you now are in this place, what you are going to have here is, and then take note of that. All right, so since you are in B1 now, that means the whole of this, right, the whole of this row and then the whole of this column is going to be left out, is going to be cancelled. So you cancel that. What you have remaining is what you have remaining is A2, A3, right? Then C2, C3. That is the determinant of that. So you now go to the last one, C1 here, plus, the sign for C1 is plus. So you now have plus C1. Now this one is still cancelled. This one now, this column now is cancelled out. So you have A2, right? Then you have B2, then you have A3, and you have B3. So this is where we now get this from, right? Where you now have A1 here, this is the A1 that you have here. Then when you have this A1, you now have B2, C3. Remember how we did for the 2 by 2, B2, C3 minus B3, C2 minus B3, C2, right? Then this minus, then B1, then A2, right? A2, C3. Right, so I think what we need to do is let's cancel this out here. Let's cancel this out, and then continue with this method. So now if we now have minus, we have minus b1 here, minus b1, which means we're going to have a2c3 here. This is into a2c3 minus, we're now going to take this one, this diagonal here, c minus a3 c2, then this is plus, we'll now have plus, we'll now take this final one, c1 into, take this diagonal here, that is a2b3, then minus, this is b3 a3, I mean b2 a3. So this is the formula for calculating the matrices. We are going to do one or two examples, and you are going to see how it's being applied. So let's solve this example. We have matrix A to be equal to this. So the determinant of A is going to be equal to, right, this is going to be 2 times minus 5, which is minus 10. Then this is minus minus 3 times minus 1, which is going to be what? Plus 3. So that means determinant of A is equal to minus 10 minus 3, which is minus 13. So that is for the first example. So let's look at the second example. So now let's take the determinant of B. The determinant of B is going to be equal to, the first element we have here is 2. So we are going to have 2 into, leaving this and this, we have minus 2, minus 1, we have 3 and minus 3. Then this is going to be minus 1, right, because of this minus. So this and this will go, we'll be left with 4, minus 5, 3, minus 3. Then we are going to be having plus 0 into 4, minus 5, minus 2, minus 1. So determinant of B is going to be equal to 2 into, let's open this now. This is going to be 6 plus 3, right, minus minus. Then we have minus 1 into minus 12, right, plus, this is 3, multiplying minus 5, then minus again, that's going to be 15, right, then this is plus 0. So the determinant is going to be 2 multiplying 9 minus 1 multiplying 3. So this is going to be 18 minus 3, which is equal to 15. So the determinant of matrix B is 15. So let's look at some properties of determinant here. Determinants in mathematics have some basic properties that, when you understand, is going to make your understanding of determinant of matrices more better, and it's going to help you in your further calculations. So here we are going to be looking at basically 3 rules that all determinants follow. So for number 1, they say the determinant of an identity matrix is 1. Identity matrix, that is matrix I, as we said in our previous videos, this is 1 0 0 1. So we'll not be doing that of 3 by 3. I will not want us to spend so much time on that. So let's look at just this one. It's a 2 by 2 identity matrix. So they say the determinant of I is equal to, right, 1001, right? So this is equal to this times this, right, 1 minus this times this 0, which is equal to what? 1. So that proves it, right? That proves it for number 1 there. So let's look at number 2. Let's look at number 2. Number 2 says if two rows or two columns of a matrix are interchanged, this one has to do with a 3 by 3 matrix. Let's consider a 3 by 3 matrix. Matrix A to be equal to, let's consider 2, 3, 4. So to prove this now, we're going to be solving this. We'll solve these two matrices. So let's solve the first matrix to see. So to solve this matrix, we'll take 2, right? Then this is 2 multiplying this, right? 1 times 2, which is 2 minus 4 times 2, which is 8. Then remember this is going to be minus 3 into minus 1 times times 2, which is minus 2. Then we have 0 times 2, which is 0, right? Then we have plus 4 into minus 4, that is minus 1 times 4. Then this is still now going to be 0, right? 0 times 2, 0 times 1 is 0, so let's leave that there. So this is going to be 2 multiplying minus 6, right? Then we have minus 3 multiplying minus 2. Then we have plus 4 multiplying minus 4. So this is minus 12 plus 6 minus 16, which is equal to what? Which is equal to minus 22. This is equal to minus 22. 6 minus 16 is minus 10. Minus 10 minus 12 is equal to minus 22. So let's now look at the second matrix. Let's consider the second matrix now. Remember our rule, right? This one has to be 22. So let's solve to check if it's correct. This is minus 1, 3 times 2, 6. Minus 4 times 4, 16, right? Then minus 1 multiplying 2 times 2, 4, right? 0 times 4, 0. And this is plus 2 multiplying 4 times 2, 8, right? This is 0. So we are going to have minus 1 multiplying minus 10, right? Then minus 1 multiplying 4. Then this is plus 2 multiplying 8. So this is going to give rise to 10 minus 4 plus 16. So let's check it. This is actually equal to 22. So they say if two rows or columns of a matrix are interchanged, then the determinant is multiplied by minus 1. So that means you multiply this by minus 1, you are going to have 22. And then we've actually done that, and this proves the theorem. So I will let you to go and do this third one by yourself. It's not difficult. It's not difficult. So I will let you to do the third one by yourself. So for instance, the first statement says if all the numbers of one row or column are multiplied by another n. So for instance here, if all the number in this row is multiplied by, let's say, number 2, then a new row will be formed, which will be 8 and 4 here, right? Every other thing will remain constant. So what that means is that the determinant is multiplied by n. That number that you multiply, which here in this case n is equal to 2. So what they are saying is that the determinant, if we find the matrix of the determinant of this matrix and put it one side, it means that if the determinant of this matrix, right, is 22, right, if the determinant of this matrix A is 22, then what that means is that when you now multiply this row by 2, then the determinant of A will now become 2 times minus 22, so which means you'll be getting minus 44. So that is what that is saying. Then the remaining part is also not difficult. So next we'll be looking at system of linear equations, where you have a system of linear equation and you have to use matrices to solve. The typical example is the Cramer's rule. So let's jump right into it in our next video.